Here in this video, we are planning to solve a very simple problem. The problem is like this. It is given that heat produced is 5 ohms resistor due to the current passing is 10 calories per second. Look at this circuit. Here is the 5 ohms resistance. It is given that there is a heat generated in that resistance. How much of that? 10 calories per second. Then what is the heat generated in 4 ohms resistor? That is, this resistance is the question. First of all, let us take the given data. How much is heat is generated? In the given problem is 10 calories per second across 5 ohms. We shall know what's the formula for that heat generated is, which comes from the very core definition of the potential itself. If you remember the definition of potential, amount of work done in bringing a unit positive charge from infinite distance up to a particular point is called potential at that point. It implies work done equal to VQ. So you have done some work to bring the charge to that place. That work is then further converted into heat, which can be written like a formula as VQ. We know the definition of current itself, rate of flow of charge. That implies in the place of Q, we can definitely write IT. So the formula of heat generated, VQ, the place of Q, you can write IT. So the heat generated is voltage supplied across it into current into time. So what is given for is heat generated per time is VI, heat generated per I. Of course, in the place of V, as V is not given for you, resistance is given for you, I can use Ohm's law, V equal to IR and I. So heat generated per second, per time per second is I square R. Now let us see what is given. Heat generated through this 5 ohms is 10 calories per second. How much is I through that? I don't know, but the resistance has 5. That implies I square equal to 10 by 5, that is 2. That implies I equal to root 2 amperes. I know the current across this now is root 2 amperes. I want the heat across this, therefore I need to know what is the current across this 4 ohms. I know the current across the 5 ohms, but I want the current across this 4 ohms. So look at the circuit. Current comes this way, get distributed here as I1 and I2. Now I know I2, I want I1. This I1 passes through the same 6 ohms because these two are in series. So if you draw an equivalent circuit, 4 and 6 is 10 ohms. At the bottom there is 5 ohms. These two are in parallel. In parallel, voltage is same. Both of them, I into R is constant. So I1 by I2 is R2 by R1. I1 I don't know. I2 is already determined, root 2. R2 is 5. R1 is this 10 ohms. So I1 is 5 root 2 by 10. That is root 2 by 2. That is 1 by root 2 amperes. That means both across this 4 ohms and 6 ohms, the current passing is 1 by root 2 amperes. Now I know the current. Once if I know the current, I can use the same formula. So heat across 4 ohms per second is I across that multiplied by R of that. I across that is 1 by root 2 whole square. Resistance of that is 4. 1 by root 2 whole square is 1 by 2 and 4. That is 4 by 2, that is 2 calories per second. So the heat that is generated across this 4 ohms is 2 calories per second. This is how we have to solve the problem. Thank you for watching.